All right, welcome back to the drive-through for a special "This is how you do proofs" version of the drive-through, sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a delicious fudge stripe cookie. Okay, so here's what we're going to do. We're going to go real slow, and we're going to show you that there are lots of good ways to do these, as long as you don't use illegal steps. What I like about this is that it uses the if sides then angles theorem, and it uses angle subtraction, and it uses segments division. And those are the three theorems that I think many people are struggling with the most. So, first, ABC is isosceles with side AB congruent to side AC. Maybe it's in your best interest to bring a highlighter to this thing. Okay, I keep encouraging you to pull these things apart, but maybe a highlighter might be a better thing for you. We also know, and I know it doesn't look like it on my drawing, but D and E are both midpoints. Okay? That's what we're given. That's all we're given. And what I'm going to do is I'm going to show you two different ways to do this. So that's actually not my statement and my reasons. Here, we'll do the blue method. Okay? So I'm going to squiggle my givens for time's sake because they're written right above and I've already talked them through with you. So, from the fact that the blue segments are congruent and that D and E are midpoints, that tells me, since I have two things that are congruent to each other, and then those things get cut in half, now I have four congruent things. I know that AD is congruent to BD, is congruent to AE, is congruent to EC. All of those things are congruent, and what allows me to say that? That's segments division. Okay, I'm going to use a lot of abbreviations because I got to write so small. All right, now, the blue route. What I'm going to do with the blue route is I'm going to prove those two yellow triangles congruent. Okay? So, I've got a side. I've got another side. So, what I've got right now, if I could just write it out, I'm trying to prove that is congruent to that. I just said that those were congruent, and I was given that these two were congruent. So how do you think I'm going to prove those two triangles congruent? SAS. So what I'm going to say is that angle A is congruent to angle A. Now how come I can call it angle A? It's the only angle A. I can't always call angles by one letter. For example, can I say that angle B is congruent to angle C? I cannot. There's too many angle B's. Alright, so what's my reason on angle A congruent to angle A? Reflexive. Have I successfully proven those triangles congruent? Well, I guess not yet, but now, do I have enough information to? Yes. So triangle AB is congruent to which triangle? ACD. Okay, and my reason one more time? SAS. Now I can't lose track of what I'm trying to do. I'm trying to prove that this little pink triangle is what? Is isosceles. So there's only two ways to do that. I either got to get that these two angles are congruent, or I got to get that BP and CP are congruent. Do you agree? Alright, so I'm working my way to that. I'm going to go angles, and I have it now. I got it. The next thing I'm going to say is that angle ABC is congruent to what angle? ACB. And my reason for that? Does everybody see that? That's a big isosceles triangle. Take all the rubbish in the middle out in your brain. Do you see that big isosceles triangle there? You see it? So now I can say if two sides of a triangle are congruent to each other, which is what we were given, then the angles across from that are also congruent to each other. All right? Everyone see where I'm going with this? Now check this out. Don't you agree that we proved these two triangles congruent? Does everybody agree that? So doesn't that make these two little angles down here congruent to each other? So this triangle, this angle is congruent to that angle. Angle AB is congruent to angle what? ACD. What allows me to say that? CPCTC. What does that mean? Corresponding parts of triangles that we've already proved congruent can also be said congruent to each other. So now, what I've said was that the big angles are congruent, but these little pieces are congruent. So I'm almost there. What can I say next? Angle what? Yeah. Angle PBC is congruent to angle PCB. And that's true because if I have two things that are congruent, and then I subtract out the same thing from both, that thing being this angle and that angle, then the result is also congruent. What's that called? Angles subtraction. If you called it angle subtraction, I would take off 0 points. Okay? I don't care about that kind of stuff. So now look, the book would go right to the answer. I know the definition of isosceles triangle to be a triangle that has at least two what? Sides congruent. So this might be considered unnecessary to the book, but I will say that PB is congruent to what? PC by? Yep, that's an 8. If angles are congruent in a triangle, then the sides across from them are congruent. And finally, in step 9, I will say what? Triangle PBC is isosceles by definition of isosceles. Now, I want you to stay with me. Some of you were probably just like, oh, that makes sense. Well, I know it makes sense because you're smart, but you got to start practicing that. Okay? You have to practice these. It's one thing to watch me do them, but it's another thing to do them on your own. Because watch this. I'm about to do the exact same proof, but I'm going to do it in red, and I'm going to do it a completely different way. Okay? So now I'm going to start out with my givens. Okay? And what I'm going to do this time, let me pause. Okay, now what I'm going to do, stay with me, I'm going to peel triangle DBC apart from triangle ECB. And it's another great way to do it, okay? So check this out. The first thing I'm going to say is that angle ABC is congruent to what? Angle ACB. Don't be too concerned with writing this down. It's going to be on the internet. Okay? Just understand what I'm doing. What's my reason for that? If a triangle has congruent sides, then a triangle has congruent angles that are opposite from it. Okay. I'm also going to say that BC is congruent to BC. Reflexive. Okay, so now I've got this is congruent to this, and that is congruent to that. So, man, it'd be nice if I could just get that this side was congruent to this side. And then I'd have my SAS. How could I do that? That's right, Serby. I can say that DB is congruent to EC. Now, notice, last time I listed 4 things. I'm just not listing 4 things because I'm in a rush. I could, but I don't need the other 2. Does that make sense to you guys? So, what's my reason for number 4? It's still segments division. Notice I put segment, and I'm not even going to take a point off for myself. Okay? Do I have enough information to prove these triangles congruent? So triangle DBC is congruent to triangle ECB by SAS. Okay? See where I'm going next? This one's a little quicker, isn't it? Now I can say that those 2 angles are equal. I can say that angle EBC is congruent to angle DCB, and my reason would be CPCPC. And now I'm exactly where I was in step 7 before. So I can say that PB is congruent to PC by, if angles are congruent, then sides are congruent. And now I can say that triangle PBC is isosceles by definition of isosceles. And I hope that helped some of you people out there who I got a ton of respect for that are working so hard. Boom!